Okay, so in this video we're going to start studying about collisions. Now there are various kinds of collisions. Okay, when you think about it, a vehicle colliding with another vehicle, a ball colliding with the ground, and a football player colliding with another one. And so it may seem that there are lots of different possibilities. The good thing is we can actually classify collisions very easily. Okay, and we classify collisions based on the kinetic energy conservation. So classify collisions based on kinetic energy conservation. Okay, and we have two kinds of collisions, all right, and we call them elastic and inelastic collision. If KE, if the kinetic energy is conserved, all right, and I hope by this time you already know what is meant by the statement if kinetic energy is conserved. It means that the kinetic energy before the collision will be equal to kinetic energy after the collision. Okay, so if kinetic energy is conserved, then the collision is elastic. Okay, and if the kinetic energy is not conserved, then the collision is inelastic. Alright, so two kinds of collisions, elastic collision and inelastic collision. Okay, when the kinetic energy is conserved, it's elastic. When it is not conserved, we have inelastic collision. And once again, we classify everything based on the kinetic energy conservation. Okay, so make sure that you take the notes down for this one. Understand again, ask yourself the question: what are the two kinds of collisions? Okay, and what are they classified? So once again, answer this question: what are the two kinds of collisions, and how are they classified? But these are multiple choice questions that you will have to deal with. Okay, how are they classified? So once again, the answer to the first part is that we have an elastic collision and an inelastic collision, and we classify them based on kinetic energy conservation. Alright, so we have this. So now let us look at some examples of the two things. So first we will begin by studying inelastic collision. Okay, it is the easier of the two collisions. Now in an inelastic collision, we definitely know that the kinetic energy is going to change. It is not going to remain the same. Whatever kinetic energy has in the beginning is going to be different from what it will end up having in the end. So kinetic energy is not conserved. However, okay, the momentum could still be conserved. And once again, when is momentum conserved? If F external is equal to 0, okay, then Pi would be equal to Pf. So momentum could be conserved provided the external force is equal to 0. So make sure that you keep this in mind. If F external is 0, then momentum is conserved. Now, with this in mind, okay, let us look at an example of an inelastic collision. So let us say that we have an object of mass, say 5 kg, that is moving to the right at 10 meters per second, and we have another object of mass, let's say 4 kg, that is moving to the left at say 5 meters per second. And we ask, okay, these two collide, and what is observed? So this is say before the collision. Okay, what is observed is that after the collision, the 4 kg block moves to the right at 8 meters per second. And we ask, what is the velocity of the 5 kg block? Okay, so to answer this question, okay, the first thing is what we need to realize is that there is a collision. The two blocks are exerting forces on each other during the collision. However, since these forces are simply from one block exerting on the other, the forces are going to be balanced out. They're going to be equal and opposite, and we come to the simple conclusion that the F external will be 0. And since this is the case, what we know is we can use Pi equals Pf. We can use momentum conservation. Okay. Once you know this, the rest of the problem is very simple. Let us write down the initial momentum for for the two blocks, and let us do the same for the final. Okay, the initial in the beginning, if I were to write Pi, it would be the momentum of the 5 kg block, which happens to be 5 times 10, plus the momentum of the 4 kg block. Okay, here before you proceed, I'd like you to tell me what the momentum of the 4 kg block is. Okay, and then verify your answer. Okay, so assuming that you did this, okay, you figured out what the momentum is, let's write this down. It'll be 4 multiplied by minus 5. Okay, now the minus 5 here, this is important, and it is because of the fact that the block is moving to the left. Okay, so keep this in mind. So if you were to add this up, we get 50 minus 20, and we end up getting 30 kg meters per second. On the other hand, the momentum in the end, okay, we can write that as 5 times some unknown quantity plus 4 times 8. Okay, and this ends up being equal to 5v plus 40. Now what am I doing? 5v plus 32. Alright, now the two momentum, as we realize, are equal. So what we know is that 5v plus 32 is equal to 30. And now we can solve for v. We get 5 times v equals 30 minus 32, which gives us negative 2. And so v is negative 2 over 5. It is negative 0.4 meters per second. Alright, so we looked at this collision and we found the fact that we found the velocity using the conservation of momentum. Alright, now another thing we could do is we could check here whether what kind of collision it is, and in order to do that, we could find the total initial kinetic energy and the total final kinetic energy. Okay, so we could do this by doing 1/2 times 5 times 10 square plus 1/2 times 4 times 8 square. Okay, and then the final would be 1/2 times 5 times 0.4 square plus 1/2 times 4 times what is it? Oh no, I made a mistake. The final is 8, the initial is 5. So I'm sorry about that. So this is 5. Okay, find these two numbers and you will realize that KEI is not equal to KEF. Okay, and the collision is inelastic. Okay, so that's one problem.